Hello, my name is Kevin Dixon, and I'm doing my report on ATC radar systems. In this report, I will tell you about air traffic controllers, what they do, give a short summary, what their day to day life is like, some of their duties, and then I'll go in depth about radar systems. Air traffic controllers. What are air traffic controllers? Air traffic controllers coordinate the movement of aircraft to maintain safe distances between them. The work environments can be in control towers, approach control facilities, or route centers. Their work can be stressful because of maximum concentration is required at all times. They work nights, weekends, and rotating shifts. How to become an air traffic controller. There are several paths to becoming an air traffic controller. Candidates typically need an associate's or a bachelor's degree from the Air Traffic Collegiate Training Initiative program. Other applicants may have 3 years of progressively responsible work experience, have completed 4 years of college, or have a combination of both. One must also be a U.S. citizen, submit to medical and background checks, and takes exams and courses a part of the FAA's academy. Pay can range depending on what level airport you are, but a median salary for 2019 was $122,000. What air traffic controllers do. Their duties include monitoring direct movement of aircraft on the ground and in the air, control all ground traffic at airport runways and taxiways, issue landing and takeoff instructions to pilots, transfer control of departing flights to other traffic control centers, and accept control of arriving flights. Inform pilots about weather, runway closures, and other critical information. Alert airport response staff in the event of an airport emergency. There are 3 different types of air traffic controllers: tower controllers, approach and departure controllers, and en route controllers. Tower controllers direct the movement of vehicles, including aircraft or runways and taxiways. They check flight plans, give pilots clearance for takeoff or landing, and direct the movement of aircraft and other traffic on the runways and in other parts of the airport. Most work from control towers, observing the traffic they control. Tower controllers manage the traffic from airport to a radius of 3 to 30 miles out. Approach and departure controllers ensure the aircraft traveling within an airport's airspace maintain minimum separation for safety. They give clearances to enter controlled airspace and hand off control of aircraft to en route controllers. Approach and departure controllers use radar equipment to monitor flight paths and work in buildings known as Terminal Radar Approach Control Centers, also known as TRACONs. They also inform pilots and weather conditions and other critical notices. Terminal approach controllers assist the aircraft until it reaches the edge of the facility's airspace, usually about 20 to 50 miles from the airport and up to about 17,000 feet in the air. En route controllers monitor aircraft once they leave an airport's airspace. They work at an air route traffic control centers located throughout the country, which typically are not located at airports. Each center is assigned an airspace based on the geography and air traffic in the area in which it is located. As an airplane approaches and flies through a center's airspace, en route controllers guide the airplane along its route. They may adjust the flight path of aircraft to avoid collisions and for safety in general. Route controllers direct the aircraft for the bulk of the flight before handing to terminal approach controllers. Radar systems. There are 3 different radar systems. Of course, you have the typical technology that will be found in any control tower, such as telephones, graphs of the weather, meteorologic meteorological instruments, airport lighting, and things of that sort. But we're going to spend this time focusing on the radars. Air traffic controllers use radar systems positioned at or near the ACT facility to get a real time overview of the aircraft flying in the airspace they control. Radar technology for detecting aircraft first became popular during the wars in the first half of the last century and played a vital role in their outcome. First generation radar systems served as early warning systems. These systems had relatively poor resolution, and their only purpose was to alert their operators to the presence of flying objects in the radar's field of view. These early radars operated by emitting a continuous radar signal and listening for any echoes, but they weren't able to use these echoes to gauge the size of the aircraft, calculate its ground speed or altitude, or determine if the aircraft belonged to an ally or opposition. The first radar system we're going to get into is primary surveillance radar. The primary surveillance radar is the traditional form of radar that most people are familiar with. The radar sends a direct pulse into the atmosphere, and when the pulse encounters an object, it gets reflected back to the radar station. By having precise knowledge of the orientation of the radar and the time between the sending and receiving of the radio pulse, the bearing of the object with respect to the radar station and its appropriate distance can be calculated. The radar is typically enclosed in a dome to protect it from adverse weather. The PSR cannot determine the altitude or elevation of the aircraft relative to that of the radar station. For that is to be possible, a second radar that sweeps the sky vertically would be required. However, such technology is typically only found in precision approach radar installations at military facilities to assist pilots with landing aircraft, not necessarily necessary at an airport. Secondary surveillance radar. The secondary surveillance radar system, or air traffic control radar beacon systems, as it is sometimes referred to, is comprised of the ATC radar installation and a transponder that rides on board the aircraft being monitored. The origins of the SSR lie in the identity friend or foe system used by the military to distinguish allied and enemy aircraft, with the primary surveillance radar system for reflected radio signals. The secondary surveillance radar listens for messages from the aircraft's transponder. The radar rotates about the vertical axis similar to a PSR, but transmits a specific signal on 1030. This signal is subsequently received by the aircraft's onboard transponder, which responds with a reply on 1090 radio signal. Much like a PSR, the bearing and distance of the aircraft with respect to the radio installation can be calculated with precise knowledge of the orientation of the radar when the signal was transmitted. Thirdly and lastly, the surface movement radar can be used when the airfield can be a busy place with pushback tugs, tractors with baggage containers in tow, refueling trucks, catering trucks, airport security vehicles, and of course aircraft, while the PSR and SSR provide controllers with an overview of aircraft in the air. The surface movement radar provides a real-time view of aircraft and support vehicles on the ground at airports. Most modern airports have ground control in charge of ensuring that critical patches of the airport tarmacs, such as active runways and taxiways, are safe for moving. Ground control can observe all moving vehicles and aircraft on a radar screen overlaid on a map of the airport. Next generation technologies that will consist of, but is not limited to, any technologies that are currently being developed or in the process of being talked about. The aviation industry has been relatively conservative in its approach to adopting new technologies, so a number of the systems described so far are based on technology that has been around for at least a few decades. The conservatism is primarily attributable to the safety and reliability conservations that must be taken into account when making changes to existing equipment and procedures. When tried and true systems do provide the required safety, this safety may at times come at the cost of efficiency. Critics of the current air traffic control system claim that efficiency gains of many percentage points remain to be realized by more intelligent routing in controlled airspace that allows for lower separation distances between aircraft. And that was my project on radar systems and air traffic control industry along with the aviation space. Thank you very much.